In this video, we will see further problems from exercise 3.7. Question number 2. If a plus b plus c is equal to 2s, then prove that sine s minus a, sine s minus b plus sine s minus c is equal to sine a, sine b. So, what is given to us is that a plus b plus c is equal to 2s, and we have to prove this. Okay, the formula that we will be using is sin a sin b is equal to half of cos a minus b minus cos a plus b. Right. So, let us take the left hand side here, and let us take the first part of the left hand side, which is sin s minus a into sin s minus b. This is equal to, according to the formula, taking a as s minus a and b as s minus b, this becomes half of, within brackets, cos a minus b, that is s minus a, minus b would be minus s plus b, and minus cos a plus b. So, it is minus cos a is s minus a plus b. So, that is plus s minus b. That is equal to half of, within bracket, the s and s gets cancelled. So, you are left with cos b minus a minus s and s will become 2s, cos 2s minus a minus b. Now, we know that a plus b plus c is equal to 2s. So, let us substitute this 2s with a plus b plus c. So, this becomes half of cos b minus a minus cos a plus b plus c minus a minus b. So, again a and a gets cancelled, b and b will get cancelled. So, you are left with half of cos b minus a minus cos c. Now, let us take the second part of the question, which is sin s sin s minus c. So, that again using the same formula, sin a sin b, this becomes half of cos. Now, our a is s and b is s minus c. So, a minus b would be s minus s plus c. Minus into minus will become plus c minus cos a plus b. So, that is s plus s minus c. Again simplifying, s and s will get cancelled here. So, this is half of cos c minus s and s will become 2s, cos 2s minus c. So, now we have our sin s minus a sin s minus b equals half of cos b minus a minus cos c, and you have sin s into sin s minus c is equal to half of cos c minus cos s 2s minus c. So, therefore, we can say that our left hand side is now equal to, adding these two, half of cos b minus a minus cos c plus half of cos c minus cos 2s minus c. Further simplifying, let us take the half as a common factor outside. So, this becomes cos b minus a minus cos c, and you have a plus cos c here. Then you have a minus cos 2s minus c. Cos c and minus cos c will get cancelled. So, now we are left with half cos b minus a minus cos 2s minus c. and it's given to us that 2s is equal to a plus b plus c. So this we can further simplify as half into cos b minus a minus cos 2s is a plus b plus c minus c. Again, plus c and minus c will get cancelled. Now you have, or now left with half into cos b minus a minus cos a plus b. And you can rewrite this now as equal to half of cos b minus a, the a plus b, let's write it as b plus a, minus cos of b plus a. Now this is very similar to our formula which is given here. So using this formula we can say this is equal to sine b into sine a, which is equal to sine a into sine b, which is equal to RHS, hence the proof. Question number 3. If x plus y plus z is equal to xyz, then prove that 2x by 1 minus x squared plus 2y by 1 minus y squared plus 2z by 1 minus z squared is equal to 2x by 1 minus x squared, 2y by 1 minus y squared, 2z by 1 minus z squared. So here what is given is x plus y plus z is equal to x, y, z. So let's say given x plus y plus z is equal to x, y, z. Okay, so let x be equal to tan a and let y be equal to tan b and z be equal to tan c. Then we can say tan a plus tan b plus tan c is equal to tan a, tan b times tan c from the given expression here. Now let's move the tan c which is here to the right hand side. So this will become tan a plus tan b is equal to tan a, tan b, tan c minus tan c. We just bring the tan c from left hand side to the right hand side. So this we can rewrite now as tan a plus tan b is equal to, take the tan c which is common outside the bracket. So this becomes tan c into tan a, tan b minus 1. Now we can now rewrite this expression as 1 minus tan a tan b and put a minus outside here. So this you can say tan a plus tan b is equal to minus tan c and within bracket 1 minus tan a tan b, right. So now let's bring this expression to the left hand side. So that means you will divide it. So this becomes tan a plus tan b divided by 1 minus tan a tan b, it's equal to minus tan c. Now this left hand side expression is the same as tan a plus b. So this becomes tan a plus b is equal to minus tan c can be written as tan minus c. So this implies that our a plus b is equal to minus c. Now let's multiply left hand side and right hand side by 2. So this will become 2 times a plus b is equal to 2 times minus c, which is nothing but 2a plus 2b is equal to minus 2c. Now, using this expression here, we can say tan 2a plus 2b is equal to tan minus 2c. There's only one c here. So, further expanding this, you can say tan 2a plus 2b is nothing but tan 2a plus tan 2b divided by 1 minus tan 2a tan 2b, and our right hand side will become minus tan 2c. So, now moving this to the right hand side, this will further become tan 2a plus tan 2b is equal to minus tan 2c within bracket 1 minus tan 2a tan 2b, and that's equal. The right hand side you can expand it, and this will become minus tan 2c plus, minus into minus is a plus, tan 2a tan 2b tan 2c. Now, let us take the minus tan 2c to the left hand side. So, this becomes tan 2a plus tan 2b plus tan 2c is equal to tan 2a tan 2b tan 2c. Now, we know that tan 2a is equal to tan 2 tan a divided by 1 minus tan squared a. Now, we have already seen that our tan a is x. So, this is equal to 2x divided by 1 minus x squared. So, using this, let us replace all these expressions here. So, this will now become, instead of tan 2a, you will say 2x divided by 1 minus x squared plus, and b is, tan b is y. So, this will be 2y divided by 1 minus y squared plus 2z divided by 1 minus z squared. This is a z here, will be equal to tan 2a tan 2b into tan 2c. So, again using this, we can say this is equal to 2x divided by 1 minus x squared times 2y divided by 1 minus y squared times 2z divided by 1 minus z square. This implies that our LHS is equal to RHS, hence the proof. Question number 4. If a plus b plus c is equal to pi by 2, prove the following. So, let us take the first question, which is prove that sin 2a plus sin 2b plus sin 2c is equal to 4 cos a cos b cos c. So, let us take the left hand side of the first problem. So, let me call this 1. LHS is equal to sin 2a plus sin 2b plus sin 2c. Now, let us apply this formula, which is sin c plus sin d, onto the first two expressions here. So, this will become 2 times sin c plus d by 2 will be 2a plus 2b divided by 2 will become a plus b, and c minus d will become 2a minus 2b divided by 2 will become cos a minus b plus sin 2c. Now, we can rewrite a plus b as 90 minus c from what is given here. So, I can say since a plus b is equal to 90 minus c. So, this becomes 2 times sine 90 minus c cos a minus b plus sine 2c. Now, sine 90 minus c is nothing but cos c. So, this is 2 times cos c cos a minus b plus sine 2c. Now, you can rewrite your sine 2c as 2 sine c cos c. So, let me say, since sine 2c is equal to 2 sine c cos c, this will become 2 cos c cos a minus b plus the 2 sine 2c will become 2 sine c cos c. Now, we have cos c, or rather 2 cos c as common. So, let us take that out. So 2 cos c into cos a minus b plus sine c. Now, again the sine c can be rewritten as cos a plus b. So, this becomes cos 2 cos c into cos a minus b plus cos a plus b. Since a plus b is equal to 90 minus c. So, further from this we can say cos a minus b plus cos a plus b can be is nothing but 2 times cos c into 2 times cos a cos b. Therefore, simplifying, this becomes 4 times cos a cos b cos c. That is equal to the RHS, hence the proof. Now, for the second part of the question, which is prove that cos 2a plus cos 2b plus cos 2c is equal to 1 plus 4 sin a sin b cos c. So, again let us take the left hand side, which is cos 2a plus cos 2b plus cos 2c, and let us apply on the first two expressions the formula cos c plus cos d. So, this becomes 2 times cos a plus b into cos a minus b plus cos 2c. Now, we can say cos 2c is equal to 1 minus 2 times sine squared c. Therefore, this expression will become cos a plus b into cos a minus b plus 1 minus 2 sine squared c. We have seen in the previous problem that cos a plus b is nothing but sine c. So, this becomes again 2 times sine c cos a minus b plus 1 minus 2 sine squared c. So, let us rearrange this. Let us keep the 1 here, and sine c is common. Sorry, this is a 2 sine squared c. So, 2 sine c is common. So, take that out. So, this becomes 2 sine c, within bracket you have cos a minus b minus, sorry, this is a plus, minus sine c. Again, we can rewrite sine c as cos a plus b So this becomes 1 plus 2 times sine C into cos A minus B minus cos A plus B. Now let's use this formula onto this expression which is within the brackets. So cos C minus cos D is given by 2 sine C plus D by 2 sine D minus C by 2. So applying this onto this, you will get your solution as 1 plus 2 sine C into 2 times sine C here A sine B. So which is equal to 1 plus 4. 2 times 2 is 4. 4 sine A sine B sine C, which is equal to our right hand side, hence the proof. Question number 5. If triangle ABC is a right angle and if angle A is equal to pi by 2, then prove 1, 2 and 3. Let's take the first question, which is cos squared B plus cos squared C is equal to 1. So this is a triangle ABC. So let's say this is A, B and C. Now the angle A is equal to pi by 2. So it's right angled at A. So this is right angle at A. Now we have to prove for the first question that cos squared B plus cos squared C is equal to 1. So let's take left hand side, which is equal to cos squared B plus cos squared C. Now we can say cos B is equal to, from the right angle triangle, cos B is this angle B here. So cos B is adjacent side, which is AB, divided by hypotenuse, which is BC, and cos C is equal to AC divided by BC, which is this angle C here. This is the adjacent side and this is the hypotenuse. So this will now become AB squared divided by BC squared plus AC squared divided by BC squared. So since BC squared is common, we can have that as a common denominator and adding the numerator AB squared plus AC squared. According to the Pythagoras theorem, AB squared plus AC squared is equal to BC squared. So this is equal to BC squared divided by BC squared, which is equal to 1, which is equal to our RHS. Similarly, let's do the second one, which is sine squared B plus sine squared C is equal to 1. Same way, our sine B, the angle B, sine B will be opposite side, which is AC divided by the hypotenuse, which is BC, and sine C will be AB divided by BC. So our left hand side, which is equal to sine squared B plus sine squared C, is equal to AC squared plus by BC squared plus AB squared by BC squared is equal to AC squared plus AB squared divided by BC squared. Again, using the Pythagoras theorem, we can say AB squared plus AC squared is equal to BC squared. So this is equal to BC squared divided by BC squared, which is equal to 1, which is equal to our RHS, hence the proof. Now the third part of the question, which is cos B minus cos C is equal to minus 1 plus 2 root 2 cos b by 2 sine c by 2. Right. Since it's right angled at A, the triangle, in this triangle we can say angle A plus B plus C will be equal to 180 degrees, since it's a triangle. And what is given to us is that angle A is equal to 90 degrees. Therefore, our B plus C must be equal to 180 minus A, which is, 180 here, 180 minus 90 degrees. So that's equal to 90 degrees, which implies our B plus C divided by 2 will be equal to 90 divided by 2 is 45 degrees, or we can say B by 2 plus C by 2 is equal to 45 degrees. Let's first take the right hand side. So the right hand side is equal to minus 1 plus 2 root 2 cos b by 2 sine c by 2. Now this we can rewrite it as 1 minus 1 plus root 2 into 2 times cos b by 2 sine c by 2. Now we know that cos 2 cos A sine B is equal to sine A plus B minus sine A minus B. So applying this formula onto this, let's move it here. This becomes minus 1 plus root 2 into, you substitute using this formula, sine B plus C by 2 minus sine B minus C by 2. Now we can see from here that our B plus C by 2 is equal to 45 degrees. Therefore, that's equal to minus 1 plus the root 2 which is here, we retain it within bracket. Now it's sine 45 degrees. Instead of B plus C by 2, we put 45 degrees minus sine B minus C by 2. Now the value of sine 45 degrees is 1 by root 2. So this is equal to minus 1 plus root 2 within bracket. Instead of sine 45 degrees, you say 1 by root 2 minus sine B minus C divided by 2. Now taking the root 2 inside, this becomes minus 1 plus root 2 into 1 by root 2 minus root 2 into sine B minus C by 2. Further simplifying this, this becomes minus 1 plus root 2 and root 2 will be cancelled. So this is 1 minus root 2 sine B minus C by 2. Minus 1 and plus 1 will be cancelled. So this is now equal to minus root 2 sine B minus C by 2. So let's call this 1. Now let's take the left hand side, which is equal to cos B minus cos C. Now by formula we can rewrite this as 2 times sine B plus C by 2 times sine C minus B by 2. Again, applying B plus C by 2 as 45 degrees, this becomes 2 times sine 45 degrees into sine C minus B by 2. which is equal to, we know that sine 45 degrees is 1 by root 2. So this is 2 times 1 by root 2, and we can rewrite c minus b as sine minus b minus c within bracket divided by 2. So this 2 and root 2 will become root 2 into sine minus b minus c by 2. We know that minus of b minus c by 2 will be minus sine of that. So it's going to be minus root 2 sine b minus c by 2. So from 1 and 2, LHS is equal to RHS, hence the proof.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.